Carbonyl reactions are great. We can attack them with strong nucleophiles. It's fantastic. But there's one weakness in our old discussion. We haven't really talked about how do you make carbonyls? What if you don't have the carbonyl to start with? Well, as it turns out, the most common way to make a carbonyl is by oxidation of an alcohol. And this will make a carbonyl. Okay, so let's look at how this works. There are two reagents that I'm going to focus on here. We'll add more reagents later in the course, but there are two common reagents. One is called PCC, and the other is called the Swern reaction. The Swern reaction, or Swern oxidation, is actually not one reagent. It's a whole set of reagents, but they both accomplish the same task. PCC oxidizes alcohols to carbonyls, specifically aldehydes and ketones. And the Swern reaction, or Swern oxidation, also performs this oxidation. So let's see an example. Here's this alcohol. We could react this with PCC. PCC oxidizes the alcohol to a carbonyl. Looks like that. We could do also Swern oxidation, and people typically just write Swern. And for both these cases, instead of PCC, we could have just as easily written Swern. Instead of Swern, we could have written PCC. They're basically interchangeable for this purpose. What's happening here? Note that we are making a pi bond. Okay, that's kind of interesting. What sort of reaction makes a pi bond? Eliminations. So these oxidations are actually elimination reactions. And in fact, they are very closely related to our E2 reaction. What do we need to do in E2? Well, one thing we need is a beta hydrogen. So what happens in these reactions, and let's write up one of our alcohols, is somehow when you treat it with the alcohol with PCC or with the Swern conditions, we are putting a leaving group on the oxygen. And what happens is there's going to be a base in here that will remove a hydrogen that's beta to our leaving group. Those electrons go in, and that leaving group gets ejected. And that's what makes our carbonyl compound. Okay, why are we seeing this? Because as it turns out, if you take something like methanol and you treat it with PCC, you will make the resulting carbonyl. Great. If you take a primary alcohol and you do PCC or Swern, you will get the corresponding carbonyl. We've already seen up top this second reaction. If we take a secondary alcohol, treat it with PCC or Swern, you get a carbonyl. If you take a tertiary alcohol and do PCC or Swern, you get no reaction. What is the deal? Well, the deal is, to do this elimination, we need our beta hydrogen. Those are beta hydrogens. Those are beta hydrogens. We go to the secondary alcohol, we're down to one beta hydrogen. And look, in the tertiary, we have no beta hydrogens. So we can't do this elimination. So by understanding that these oxidations are actually elimination reactions, we can understand why, from a reactivity standpoint, different alcohols work fine. Methyl, primary, secondary are fine, but tertiary does not work because it can't do the elimination because it lacks a beta hydrogen. So these are oxidations. It's a great way to make carbonyls from alcohols, and they're very commonly used when you talk about nucleophilic additions as a way to make your carbonyl.